Acids, bases and salts. Arrhenius concept of acids and bases. According to Arrhenius theory, acids are substances that dissociate in water to give hydrogen ions H plus aqueous, and bases are substances that produce hydroxyl ions OH minus aqueous. The reaction can be represented as Ha aqueous gives H plus aqueous plus A minus aqueous. The proton or hydrogen ion binds itself to a water molecule and form H3O plus ion, which is called hydronium ion. Base MOH aqueous in aqueous solutions. MOH aqueous gives M plus aqueous plus OH minus aqueous. The Bronsted-Lowry acids and bases. According to the Bronsted-Lowry theory, acid is a substance that is capable of donating a hydrogen ion H+, and bases are substances capable of accepting a hydrogen ion H+. In short, acids are proton donors and bases are proton acceptors. For example, in a reaction between ammonia NH3 and hydrogen fluoride HF, ammonia acts as a base, accepts a proton, while HF behaves as an acid, donates a proton. NH3 plus HF give NH4 plus F minus. Consider the example of dissolution of NH3 in H2O, represented by the following equation. In the forward reaction, NH3 accepts a proton from H2O. Thus, NH3 is a base and H2O is an acid. In the reverse reaction, H plus is transferred from NH4 plus to OH minus. In this case, NH4 plus acts as a Bronsted acid, while OH minus acted as Bronsted base. The acid-base pair that differs only by one proton is called a conjugate acid-base pair. Therefore, OH minus is called the conjugate base of an acid H2O and NH4 plus is called conjugate acid of the base NH3. The species NH4 plus and NH3 are called conjugate acid-base pair. If Bronsted acid is a strong acid, then its conjugate base is a weak base and vice versa. Lewis acids and bases. G.N. Lewis in 1923 defines an acid as a species which accepts electron pair and base which donates an electron pair. In Lewis' concept, many acids do not have proton. For example, the reaction of electron-deficient species BF3 with NH3. BF3 does not have a proton but still acts as an acid and reacts with NH3 by accepting its lone pair of electrons. The reaction can be represented by BF3 plus NH3 give BF3 NH3. Electron-deficient species like AlCl3, CO3+, Mg2+, etc. can act as Lewis acids, while species like H2O, NH3, OH-, etc., which can donate a pair of electrons, can act as Lewis bases.